Today we're testing Qwen 3.6 27B versus Claude Opus 5. Let's start. So we know that this test is not going to be a fair test, but I still wanted to do it because I wanted to know the gap between the Qwen and the Claude. However, there is a surprising factor in these tests and we're gonna meet what this surprising fact is. So let's start it. So for the first task, we start with something with easy. Both models had to make a command line Java application that read customer orders from a semicolon separated CSV file. It needed to validate the duplicate IDs, countries, monetary amount, Boolean values, and coupons. It then needed to calculate discount, shipping, VAT, and final total generated the three separate reports. Claude Opus 5 did really good job in this first task, but it has a pure weakness when it comes to precision, especially in counting. It did rounded the subtotal before checking the VIP 20 threshold, and then incorrectly received the discount even though the original subtotal was below 100. The Qwen, however, did also a good job, but the report in the CSV was completely corrupted. It had rows with invalid records, contained semicolon, but were not properly coded, causing required 3 columns row to become several columns. It also duplicated the handling, also had a semicolon weakness. Now here the surprise that we did with Qwen 3.6 27B. This time we provided the rigorous skills for Qwen 3.6. I'm not talking about 1 or 2 skills, I'm talking about a full set of skills that it needed. And it surprisingly did much better in tasks. In this task, for example, that was easy, it did not do very much better, although it did really good, and the only weakness was the duplicate IDs. But as we progress, it will be more clear that rigorous skills are the main thing that Qwen needs to keep up with Claude Opus 5. Now let's go to the task number 2. So for the prompt 2, the models received one file containing customer order and another containing the payment records. Both have been provided into the prompt. They had to determine whether each order was unpaid, partially paid, fully paid, or overpaid. They also had to handle pending and reverse payment, duplicate payment IDs, currency mismatch, unknown orders, invalid values, and overdue calculations. The program then needed to generate order reconciliation, payment anomaly, and currency summary report. So for this task, Claude did a great job, but it malformed records were handled individually, and invalid numbers or time step became an anomaly, and processing continued for the remaining record. So this kind of behavior also makes it continuously to following the requirement that one bad record must not destroy the entire reconciliation run. The problem with Qwen came when the input was malformed in a realistic way. So a complete row containing non-money as the amount or an invalid time step could cause the entire application to terminate with a parsing exception. On the other hand, the Qwen 3.6 with rigorous skills did way much better and did everything correctly, handled demand form payment, but it had one problem. The issue was the anomaly output file, because the original payment record contained semicolons but was not correctly escaped, causing the report to contain more columns than required. But in general, it did much better than normal Qwen 3.6 without these skills. So let's move on to the prompt 3. So on the third task, they had to reconstruct user seasons from web events arriving out of order. A new season begins only when the gap between the two events is strictly greater than 30 minutes. Exactly 30 minutes must remain in the same season. The models also had to generate endpoint statics and detect security behavior using rolling time windows. It was 3 tasks: repeated logging failure, repeated forbidden requests, and repeated checkout errors. Finally, the application had to scale to 1 million events without quadratic comparisons. Claude Opus 5 did very good in this task. The only issue was actually a small performance concern, was that copying increasingly large lists of matching event IDs could still become expensive during an extreme burst of security events. Qwen produced correct reports for the sample input, but it had the serious time boundary bug. It did not handle the security very well and had the nested loop rolling Windows implementation. Now on the Qwen 3.6 27B, this time with rigorous skills. It did not have the same mistakes that it did with the normal Qwen when it comes to the timing. But it did not exclude event exactly at 30 minutes. It did at 10 or even 20 minutes. And also it had the security risks and also the nested loops again. Let's move on to the prompt 4. So for the prompt 4, this was the first major concurrency challenge. Both models had to create an in-memory inventory service supporting reverse, confirm, release, and expiration operations. The service had to guarantee all or nothing multi-SKU reservations, no negative inventory, request IDM potency, safe expiration, no deadlocks, and result consistent with a valid serial order. The benchmark included high contention, overlapping multi-SKU request, and a race between confirmation and expiration. Claude Opus 5 did really good again. The only small weakness was involving custom reservation ID generation, which with colliding test generator to disjoint operation could receive the same reservation ID. On the other hand, the normal Qwen 3.6 27B was a complete failure in this task. The source code seems to acquire every required SKU lock, but it returned from inside the first loop iteration. That means it only ever held the first lock. The benchmark included opposite order test. Its IDM potency information was also split between separate concurrent maps. Another thread could observe one map entry before the corresponding entry appeared in the other map. Confirm, release, and expiration state changes were not sufficiently serialized either. It included 40 tests and it passed all of them, but it did not test the right lock combination. Now this time Qwen 3.6 27B with rigorous skills. It did substantially stronger and much better answer. Its primary weakness was for IDM potency for rejected requests. Rejection were not stored as original result. The same request ID could first return rejected and later return active after stock condition changed. This is the first task that we see these rigorous skills are very helpful to the Qwen when it comes to the very hard questions. With that said, let's go to the hardest prompt, task 5. So this was the most difficult task between these 5 prompts. The models had to build a production-style order import service that validate batches, calculate discount and VAT, reserves stock, persist order, handle retries and IDM potency, prevents concurrent overselling, roll back to the entire batch on failure, and write transactional outbox events. The Outbox publisher also needs to survive broker failures, retries with exponential backup, and prevent two publisher instances from processing the same event simultaneously. The Claude was extremely strong on this task. 71 passing tests with 0 failures. The only problem that Claude had with this prompt was that very slow broker calls. If a broker lasted longer than event lease, another publisher could potentially reclaim the event. The final success or failure update also did not fully verify that the publisher still owns the claim. And now for Qwen. I don't know what to say, but Qwen 3.6 27B was a complete failure in this task. Everything failed and very few things that it could do correctly. But when we add the rigorous skills to the Qwen 3.6 27B, everything changed and it became very much stronger model. The biggest weakness for this model with rigorous skills was the concurrent IDM potency. The service used a find then insert pattern, so two same key requests could raise and one could receive the database exception rather than the original successful response. There was also no strong database uniqueness guarantee for the combination of supplier and external order ID, leaving a possible concurrent duplicate order race. And same as the Claude Opus 5, here Qwen also had the problem with the broker that they were very slow. But Qwen did one thing interesting, that in the test it did close the transactions, so the broker could potentially do faster, but it did not restart and do the same process in the real application again. It just did it in the test. So that's it. That's the test that we ran. I always wanted to benchmark these models in real tasks and not just some prompts that are not useful. I will do exact the same test again next week. This time we are going to have Qwen 3.8 27B. You can also find all the project files for this video in the description below. I will also include the rigorous skills, so have fun. Now, if you like this video, please give it a thumbs up, subscribe, and as always, thank you for watching.